So the intent of today is going to be to go over the key underlying physics and science and mathematical reasons why we want to use product techniques in order to shift left and shift right, which is something that oftentimes is forgotten. And we're going to be going to how you can really win at scale by using these techniques. Lots in it for you. Thank you so much for being here. Let's go ahead and get started. The University of Maryland's Project Management Center for Excellence. I'm a faculty specialist, and I am the co-creator and founder of the Maryland's uh, Professional Studies Product Management Master's degree. Let's not be fooled. Fundamentally, it is unfair to hold product managers or entrepreneurial system designers responsible for product failures if you require them to use conventional development. The probability of failure is very high. It's well established, and the payout is low because, of course, you don't own the company, and therefore you don't have that high side risk to balance out the likelihood of failure. This is part of the reason why, when looking at kind of the way in which systems work, one of my favorite authors, who's, can be a little rough around the edges, Nicholas Nassim Taleb, he said that mild success can be explained by skills and labor, but wild success is attributable to variance, which essentially means getting lucky. So traditionally, there are two solutions to doing to addressing this failure mode. And the failure mode causes us to want to either get rid of the risk or give the risk to those who are willing to take it. So committees essentially absorb risk and nobody gets in trouble, and the decisions are subpar or average. I don't know if we want average decisions. And then the other option is simply to let the risk takers take the risk, and some of them will succeed and some of them will fail. And as much as we wanted to attribute to their greatness, most often it's just a matter of luck. Let's de-ice this idea of risk. Let's talk about risk, understanding that risk can be negative or positive. Let's talk a little bit about what are the sources of risk. Can you identify the top 5 reasons? So go ahead and put them in the chat. I've enabled the chat for now. Let's go ahead and roll with what are some of the key sources of risk in terms of why projects and products fail. Feel free to use the chat. It should be enabled. Core requirements: being to run scope, lack of data, communication, absolutely, communication gaps, ever-changing priorities, lack of customer understanding. Scope, it's always about what are we supposed to be doing? Very good. So, yep, keep it coming. I'm going to show you the list of top reasons based upon Project Management Institute's investigation of this problem. And as you can see, there are exactly what it is that you're saying: changing priorities, issues with objectives, issues with requirements, inaccurate cost estimates, right? Lack of understanding why. Yes. But if we were to break all of these things down and we were to take a look at what is the underlying cause, I'm going to argue that the top risks are about deciding what to do. And the other risks, which dog us, are deciding how to do it. And so we're going to get into how we can improve the deciding what to do and deciding how to do it. And as you can see here, all of this is about deciding what to do in terms of being able to set vision, get the right priorities, keep those objectives in mind. I'm going to argue that a lot of the shifting priorities are actually not shifting. They just weren't correct in the first place. And that deciding how to do it is also very tricky. And we oftentimes jump to solutions way too early. So when we talk about delivering value and being successful, I'm going to go ahead and steal something here from the SAFE framework, which is talking about where do value come from. Value comes from the fact that we have a customer and the customer has needs. We start by usually organizing around that customer in small groups whenever we're building new ventures. And because we're totally focused on the customer, deciding what to do is easy. We just talk to the customer, talk to each other, figure out the right solution, and we just go do it. Deciding how to do it is easy as well. Our options are usually limited, and we know that whatever we build, we're going to have to support so we don't overbuild. But then as we grow, we end up with enormous amounts of of structure in order to do things efficiently. And that puts tension on these teams. And famously, as safe presentations will show you, what happens is the team's orientation around the customer breaks apart and gets destroyed. What we want is some kind of balance between these two. And what product management offers is the ability actually to solve a problem that SAFe does not get right. So I did steal all that from SAFe, but let's be clear about something. The new thing that SAFe doesn't do well when it comes to how to organize and be able to shift left and right correctly is that it completely fails to teach product management skills. And it doesn't identify the fact that product managers are the ones who can understand what's possible and to work with a tight team, the triad, right? The designer and the expert engineer to come together to form an understanding of the intersection of what's possible for business technology and the user experience. And here's where what is changing is that by strengthening the product management function and actually in many places introducing it, we're able to create customer centricity in the organization itself, essentially infiltrating and removing a lot of that tension by giving power to those who understand the customer and whose job it is to really understand what to do. In order to understand this a little bit more fully and to also get into the reasons why we need to outlearn the competition, we also need to have a good sense of how organizations are going to deliver value. So all organizations are have what we call value streams, which operational value streams deliver value directly to the customer. Usually it starts with some trigger event, such as somebody needing a loan. And then by the end, there is some sort of value in terms of value creation where a loan, for example, might be repaid. And along the way, in order to complete all the steps, you need solutions. And those solutions might be things like how do you attract customers with channels, a system for originating loans, understanding credit scores, and doing basic banking. If you are in a company building solutions for this business, you would be developing updates to these systems. And in order to be effective, you would want to be as fast as possible at responding to a signal of a need for a new feature or a new capability, and then being able to define, build, test, and release that so that these systems were as high performing as possible so we get as much throughput as possible. That's the basic premise. And if you look at cross different organizations, there are lots of different types of business value streams out there or operational value streams. Of course, we just talked about loans, but you can have manufacturing streams that help to develop vehicles. You can have operational value streams for software products. And then, of course, you could have other sorts of supporting operational value streams that could be internal or external. In the government, we also have a number of them. We have the kill chain for conducting defense. We have the ability to rapidly, for example, deploy COVID tests, which was essential for us through COVID, as well as the development of new vaccines. And we have value streams that do things like, investigate potential areas of fraud, which we're hearing a lot about today. The whole idea is that if we organize into development value streams, then we can get together in what are called cross-functional teams, where all the functions, business, product, hardware, software, quality, etc., especially operations and security, they're on the team, and everybody works together to build a high-performing solution. The benefits of this, which we're going to reiterate a few times today, are fewer handoffs, super key to reducing knowledge waste. It's much easier to build in quality because you have downstream input and you have also the ability to understand potential dependencies across all these functions. You also learn together, so you know what you're building and you know why you're building, which is what a lot of people put in the chat. And then you're able to build in this alignment and ensure that you optimize the system as a whole. Now, this looks very software centric, and not all products are software centric. Well, not all products are software itself. I would say just about everything is being driven by software these days. But if you look at the trends in the construction industry in terms of how they are operating as well, they also are moving towards integration. In fact, this is a couple years old data, but what it shows is that current processes where they use what's called design, bid, build, which is architecture does their work, then construction does their work, no overlap. that level of delivery method, the prevalence of that delivery method is only about 1 in 3 projects. Most of the time, even in the construction world, we are integrating teams and we're overlapping functions so that they have this ability to work in a cross-functional way. And in fact, the most popular, rapidly growing approach is a design build approach, which is fully integrated. And some of these actually get to the point where you even form joint ventures with the client so that you have the whole life cycle of a building as your concern. And so this is a move to become more integrated, even in industries which we see oftentimes are perceived as being linear, right? If anyone has ever been in the project world, everybody talks about, well, when you build a building, you got to do it with waterfall. Not true. So why are we integrating teams? The number one reason is to reduce what's called knowledge waste. Knowledge waste comes in three main forms, and this comes from, again, the work of Alan Ward, which is fantastic and foundational to any kind of product management or agile at scale. And these three types of knowledge waste are realized in a couple of ways, but knowledge waste includes things like scatter, where people aren't able to communicate with each other clearly or easily, or they have really bad tools for transferring knowledge. Think complicated wire diagrams being handed over from a systems engineer to a developer, and them just giving you a look of total confusion. Another one is handoffs. Handoffs are the biggest source of knowledge waste, mainly because we can't capture even close to all the information that we gather when we interact with customers or interact with any of the internal customers or downstream functions. All of that interaction usually gets reduced down into small amounts of information we can put on a page, which then are not fully translated to somebody who reads it. So handoffs create huge amounts of knowledge waste and loss, generate lots of useless information. People never read the requirements. People never read the manual. And everybody is waiting for somebody else to get done with their part and hand it off to them. And that waiting also creates lots of delay. And then lastly, there's wishful thinking, where we are hoping at the beginning that we know exactly what the customer needs now and will want. And then we end up then at the very beginning quickly diving in and creating hard specs that aren't actually well defined or tested. But we end up building and testing to them, and we discard any knowledge we would have developed if we had explored broadly. So these are the sources of waste we need to reduce. And this is the reason why we see this shift from project teams, which are temporary, to product teams, which are long lived. Project teams have scope and output. They're doing programs that are optimized for resource efficiency, which creates even more weighting because of high levels of utilization. But product teams are looking at optimizing for flow. So they will add additional capacity, especially to keep parts of the flow of work, where there are bottlenecks, focus on outcomes, and their goal is a behavior change. So while the product teams retain knowledge, the project teams, they create knowledge, but then they store it in lessons learned, never to be retrieved again. So we want to use product teams so that as we get strategic objectives, we can go through this process that we talked about in the previous webinar, which is going through a staged approach of discovery. And these aren't waterfall. This is the idea of let's start with strategic objectives and then let's begin attacking them early with looking at the business model and testing out the hypotheses to understand, is this even a problem we're solving that people care about? Do we want this customer? Does it fit us? Do they fit us? Do we want their problems? And then also, is this a market where we think we can win? Once we understand that, we get our cross-functional triad, the product manager, the designer, and the dev lead or engineer lead, and they are going to be exploring and figuring out how to create value, making sure that we're tackling all of the four key risks of products, which is value risk. Is it actually creating value for the customer? Can the customer use it? Is it feasible? Can we even build it, especially at scale? That's especially why you have the engineer. And then also viability risk. Does it work for us as a business? And it's at that point we then, upon validating that this is worth building and worth scaling, we move into a delivery mode of tackling all the illities around making sure something will work. And so, just so we're clear, this is not waterfall. This is a form of dual track Scrum, but really, it's a form of these teams. The same people are doing the work on all three of these processes. This is simply about the types of work that you do on a cross-functional product team. So now that we've oriented, we've got these two sets of key risks that we need to address. Let's start off with number one, deciding what to do. Let's dive into that. So we've talked a little bit about this already, but I want to reiterate that becoming cross-functional allows us to ruthlessly focus on solving customer problems because we're able to have the whole team look and see whether or not what we're doing is actually having the impact that we want. And therefore, we're going to orient around outcomes and actually achieving behavior change and lists in terms of business and customer happiness and outcomes. We want to be experimental then because we don't want to just produce things. We want to make sure that we're actually building the least amount that will actually achieve the outcome. And it's a place where leadership enables and empowers teams because they know up front they can't tell you what to do. They can only help to set the goal. Remember that in these kinds of organizations, strategy is not a list of features developed by the C-suite, nor is it sourced directly from the customers. And this is something I just want to pause on because too often this idea is, oh, if we just talk to the customers, they'll tell us what we want and we'll build it. That is not correct. The reality is that your customer does not have the knowledge of what your business can support, nor do they know what the technology can do. They can only express needs and ideas, but in the end, you need to drive at their underlying intent and solve that problem as an expert. In addition, we can't just look at the competition because they're not the source of value and they may be doing the wrong thing. And it's not a list of features that attempts to cover all aspects of the product because only part of the product is likely going to be really valuable. And we definitely don't want to be pulling people in lots of different directions. This idea of creating what are called, feature factories, this is what we see with the build trap. And unfortunately, the majority of product managers today are stuck in it and they need help to get out of it. We're advocating for their release. So we want to get away from this idea of we're measured by how much we create, not the impact of our work. What drives it are gaps in our understanding and gaps in our strategy. And I'll quickly go back over this again because it's worth repeating. But there's this knowledge gap, which is the difference between the outcomes that we want to achieve and the plans that we make to achieve them. The trap is that we demand lots of information from teams, and the solution is instead we set a business goal and let them figure out the right plans to get there. Then there's this gap between the plans that we create and the actions we actually take, because a plan is immediately wrong, especially a Gantt chart after it's created. And so we want to make sure that instead of demanding lots of detailed instructions and specifications up front and in a strict timeline, we want to let every team figure out how to achieve the intent in their own way. And then lastly, there's the effects gap, which is the actions that we take and are they actually achieving the outcomes? And the trap is to rigorously use controls that are going to try to ensure that we get the outcomes that we're looking for, but it's really just output. Instead, we should let teams have freedoms to set their own plans because they'll know how to get there. And they're the ones that have all the knowledge about the work they're doing. So what we want to do then is we want to make it clear about the difference in terms of levels of concern. Company level concerns are vision and strategic intent, while product team concerns are about the initiatives and their options. If you want to understand kind of the framework that we can think about in terms of how do we get the vision level, the company level, Joshua Arnold has a good theory of value exchange that is offered that it's subjective, it's created based on a voluntary exchange, and that competition drives the creation of new levels of value. And it can be measured by willingness to pay, which we can test for on teams, and that it will always change. Therefore, if we want to create more value, we need to consider how can we either increase or protect our revenue, reduce costs, or avoid costs altogether. And we do so by interacting with the market and our customers. To think about this on a long-term scale requires developing a vision. These next couple of slides come from a good friend of mine, Daniel Forrester. Daniel Forrester has developed a wonderful course on generating and setting vision that you can take on edX. But the shorthand is going to be that there's a couple of ways of developing vision at the company level. They can be things like a transcendent belief, an expansive future value proposition, the clock ticking outcomes. By the end of the decade, we shall put a man on the moon, most famous vision statement of all time. Or it can be about exploiting technology convergence, which we're seeing a lot of today. But the one that we most recommend is this idea of big ideas. So getting big ideas right. Big ideas are a statement like a laptop in every home, or live among the population, or culture is our strategy. But the big the big ideas are what we need to get right, which is exactly what General Petraeus said, that the job of a leader is first to get the big ideas right, and from there, you can then fall out all of the correct actions we need to do to get moving in the right direction. So big ideas come from understanding both your customer, consumer, and the employee. And through big ideas, we want to drive again this concept of behavior change. And the elements or the characteristics that we should see is that a big idea should be concrete and clear. It's not business as usual. It is going to be unifying, and it takes time often to get right. It takes a lot of iteration. It's one of those things where less is more, which is something that I always need to keep in mind. In terms of how we can ensure that we're addressing and developing big ideas that will be meaningful for everyone at all levels of the company, we want to understand kind of the scope of these big ideas. Oftentimes, we think of tactics on more of the 18th month timeline. Strategy is 2 to 3 years. Vision is 5 to 10 years. Big ideas should span all the way across these and help us to drive towards a really clear outcome that we want for our customers. So once you've set that big idea, you then want to create a means of getting there. And the best way to do so, we talked about this last time, but good to reiterate, is this idea of a flywheel. Here, I'm going to show you Amazon's flywheel, which is based upon their business model of being a two-sided business model between customers and businesses, where people can go, they can find, purchase, deliver, and review products from others online, right? It's the everything store. Well, Amazon has at its core the capabilities of being the greatest logistics company of all time. If you look at their flywheel, it's quite clear, and it starts with low prices and fast delivery, which attract customers, and those customers attract sellers, and then the sellers, as you grow the number of sellers on your platform, you get higher returns on investment of your assets. And when you do that, you're now able to lower prices further and offer even faster delivery. This is combining a number of ideas from a number of good thinkers. One of them is Clayton Christensen. He talks about the idea of functionality, reliability, convenience, and price. Amazon is basically at this point continuing to drive on convenience while maintaining price, and they'll continue to do so probably until we're all just getting drone deliveries, to our windows, because it allows them to have healthy profit margins. Now, from that flywheel, you have major objectives which allow you at a company level to then develop what we call key results. Key results are measurable, measurable either inputs, outputs, or outcomes that the company wants to do under some time period. So they are time bound. It's kind of like a SMART goal, but a little bit thinner and a little bit more flexible. And what you see here is an example is that if we had a company that had an objective of driving up sales, they might want to create one set of key results that is about getting leads, another one about signing deals, and another one about creating a new product. In doing so, they could direct their functions, if they are marketing, sales, and research and development, to achieve those key results over a time period. And then teams that work for those groups would be able to align for themselves in terms of how they would go about achieving their own KRs. So for the marketing one, in order to balance out, we may want to have click-through rate of 10% of all of our ads, be number 5 on the SEO keywords we want on Google, and then get a 20% subscribe rate. Those are all key results that drive mostly with outcomes. For sales, it would be about, you may have to do 5,000 calls. That's an input. Deliver 1,000 quotes. That's an output. But then you want an outcome of customer satisfaction of 90% to make sure that our salespeople aren't beating up our customers to get and achieve their goal. So we want to balance, and that's an art. And then in addition to that, you may have one area in development where most of your work is simply explorative. So it's a lot of input. Do 100 surveys, sell 100 prototypes. That would be output. And then deploy by Q3, also output. Now, this kind of OKR where everybody kind of on each team then sets their own team OKRs and direct towards these functional OKRs that roll up to the company level. This is looser and it's called directional. When they are being flowed down, it's called directive. So the OKR planning cycle is something that a lot of companies, the best companies, are currently using, and it's a really easy framework for deploying strategy, but it is hard to master. And the idea is that you have a cycle that works on both an annual and a quarterly planning cycle, and essentially you brainstorm and set OKRs. You communicate the company-wide ones, then teams come up with their own. And then during the cycle, you're tracking against them, and then you reflect and score right about the same time that you come up with the next quarter. And so it's kind of a continuous rolling wave of setting these OKRs. Now, the OKRs at the team level offer us the chance to start doing the kind of learning that we need to do in order to tackle our big problems. We pick a KPI that we want to improve. We draw the line. That's going to be our OKR. We then look for how can we actually go about improving it? How can we increase adoption of this feature? Or how can we elevate the number of satisfied customers from 80% to 95%? Well, we could do that either without data, making a guess, or we can go in and dive into our data and look at the patterns. Based upon that, we're going to come up with a guess about what to do. And we're either going to design a prototype or just make changes in production if we have that kind of capability. And after we do so, we're essentially run a test. We're going to measure the results and ask ourselves, did we achieve what we were going for? And if we did, great, go tackle the next OKR. If we didn't, consider the reasons why, think deeply as a team. You may realize that you could do better and draw the line a little higher, or that you need to redraw that line, or just try again and go reiterate back. And that's going to be your most common feedback path. This is called the lean analytics cycle. And what's different about it from normal KPIs is that it drives the attention of your team, and it flows up to your key company metrics, your North Star metrics that are going to help you to guide all of the work. The different types of OKRs that we'll go after will be things like committed OKRs, which are usually about input and output, and we're going to do it. And I'm going to show you how you can ensure that you do. The aspirational ones are the ones where you're going to be iterating a lot, because you may only get to 30 to 70% of the actual measurable result that you want. But you're going to continue to try because it's worth it, and it's a problem that you need to solve to achieve that big vision. And of course, you could have a learning one, which is just to simply gather data. But why are we prototyping? Why are we doing this? I mean, here we are halfway through. Have we really learned how to outlearn the competition yet? And I'm going to tell you that the underlying reasons are actually much more tangible than you might think. So let's play a quick game. We're going to do this together. You have the opportunity to pick a 3-digit lottery. You must first pick your 3 digits. It can be between 000 and 999. And then you can either choose option A or option B in terms of how to collect money from this lottery. All right. So you've already picked your number. You already have it. You can't change it. Locked in. Here's what your options are. Option A, you can pay $3, and if you got it right, the payout will be $3,000, which for those doing the quick math, that's a fair game. Or option B, you can pay $1 and one digit will be revealed to you. Then you can decide to quit or continue. Remember, you've already picked your 3 digits, right? So if the first digit doesn't match, you probably know what to do with it. Then you can pay $2.50 to see the second digit and then choose to quit or continue. And then lastly, if you decide to continue, you have to pay $25 to see the last digit. And only then, if all three match, do you get $3,000, which means that you have a cost of $3 and a payout of $3,000, or you have a cost of $28.50 or a payout of $3,000. Option B, because it's all about options. Ooh, we got some A's. Let me show you why. Option A, you've got $3, a 1 in 1,000 chance of getting it right, payout of $3,000. Your cost is $3. Your expected value is the product of the chance and the payout. So now the actual expected value is going to be $3 minus $3, so it's $0. However, with option B, there's only a 1 in 10 chance that your first digit will match the first digit of the drawn lottery. So, you are definitely going to pay that first dollar, but then there's only a 1 in 10 chance you're going to pay to see the second digit. And there's only a 1 in 100 chance that you're going to pay to see the third digit, which means that the actual cost expectation is much lower and that the expected value is actually much better. So if we look at this, you don't save anything on the first digit, but you save 75% on the second digit and 75% on the third digit because there's only a 1 in 10 chance of spending $250 and a 1 in 100 chance of spending $25. And it's this understanding that you can actually create a game where people should always play. They should always win because you're guaranteed to win. That we want to use prototypes. Prototypes gives us the opportunity to pull forward information. This creates what we call an asymmetrical payout curve. So you have this normal curve in terms of the likelihood of outcomes, but you have an asymmetrical payout, and it results in essentially a higher value than zero on things with chance. And this is actually the same way that options are priced in the market, and that's why so many CEOs value them. And essentially, what we're doing is we're taking the information curve about doing a thing, which goes up over time as we execute work on a project. We learn more, and as we complete work, we learn more, and yet our ability to make changes and the risk and uncertainty is highest at the point where the cost of changes are the lowest. Our ability to change goes down over time as we work on a thing or as we learn, and we essentially run out of technical options because we're getting close to the end of a project. What happens when you use prototypes? When it happens when you test early and often on the ideas of what you're going to build for any of the key risks, right? Value, feasibility, viability, and usability. Then what you're doing is you're taking what we call the knowledge gap, the difference between our ability to change and the knowledge we have about what to change. And we're essentially shifting it left by testing early. This is the left shift. So we're reducing the knowledge gap. And in terms of companies, that's what we see as well. Those that are able to learn quickly, early, and able to pull forward, they're able to essentially win. And what you just don't see is you don't see all of the things that they stop doing because they learn quickly that it's not working. So that's the key to the reason why we use prototypes. All right, so some OKRs that you develop won't need any scaling, and therefore we can just use agile empowered teams and adopt and we're able to deploy regularly. And we can just go through the build, test, learn cycle We go through our customer discovery with lots of early MVPs, customer surveys, other forms of interaction, or we're going and we're driving our outcome OKRs with the ability to go through the lean analytics cycle I explained earlier. And that's effectively what DevOps teams are doing. And if you're in a cloud native situation, then you can do this, right? Because your services are really fairly loosely coupled, even decoupled. Your ability to deploy is probably limited by the number of checks you need in order to get the stuff out the door. And you can go through the cycle actually pretty rapidly. You know, companies are deploying thousands of times a day, but not every company can do that, right? So we want to be clear, even if you're in a company that doesn't have that kind of DevOps maturity, what else could you do? Well, the reality is that you can still do prototypes. You can still do the surveys, and AI makes it so easy now to gather data from across large sets of surveys. We'll talk about that next time. Then also product discovery. You can continue to do these kinds of prototypes, but it doesn't have to be full prototypes. In fact, most of the time, it's prototypes that you will never ever use again, except to inform what you're going to do next. And you can do this through a couple of different techniques. Some of them include things like a customer discovery program. Other types would be things like, using alternative sub brands. There are lots of ways to go about it. And then you scale up once you've done enough of the discovery work that you need in order to tackle all these key product risks, and the customer slash value stream risks. So the key then is that we want to continuously learn and improve. And one of the best frameworks for kind of understanding the strategy approach to this is the product kata, developed by Melissa Perry. And so what she has said, and what we're going to cover here briefly, is that we need to start by understanding the direction of our company. The first step is always to understand the direction of whatever it is that you're doing. The second step is going to be to analyze the current state. Where are we? What do we know? Then we're going to set a goal about what we want to do in order to move forward and step up our level of knowledge. And then we're going to choose that step. And we're either going to do problem exploration, solution exploration, or solution optimization. And so this is effectively customer discovery, product discovery, and then product delivery. And you'll actually iterate through this. And as you go through the top level, you're going to be hitting up problem exploration, and then potentially some solution exploration. And then when you come up with more initiatives, you're going to be doing solution optimization. So effectively, what we want to do is, from all those strategic opportunities with good vision setting that we've talked about, we want to have intents, not goals, but intents given to our teams in the form of a strategic goal that, again, is not setting the output. It's an outcome that we want to achieve, because this is going to be a good company level OKR. And then given to the actual product teams, they're then going to go through and generate the hypotheses that we talked about. And they're going to go through the process of doing the product kata, and then coming up with potential options from exploring the problem and potential solutions that can then be refined. So this is the vision and strategy part, and this is the product management part. And this is where product managers can start to really learn quickly by doing all this early exploration. And there are lots of different types of exploration that you can do. The idea is that when we're exploring the market, when we're exploring the problems, we have ways to generate ideas about what we could do, and then to analyze them. So this is the generative and evaluative market approaches. And then when it comes time to hone in on a solution, we can explore solutions this way through solution interviews, demo pitches, concierge tests, and then we can actually begin to converge and figure out which one is better by using different types of prototypes mostly, and then eventually A/B tests, but only once we get closer to the end. Too many times we jump to A/B testing and we haven't even gotten close to understanding these early parts. In the previous webinar, I provided some information that came out of the continuous discovery book that is quite good. And I suggest you take a look at that. And I will provide some links to that as well. So deciding what to do, we have tackled this. What we've talked about is we need to set the vision. That vision should be based upon outcomes. It should be a big idea. And then we need to use OKRs to allow our teams to go explore and figure out, okay, what should we do? How should we get there? And what will be the actual implementation? And they will be able to solve that for us. Now let's get to deciding how to do it. How to do it is a little bit less of the risk issue, but I'm going to argue um, we will need a lot of changes in how we build in order to do this effectively, because oftentimes this is where a lot of waste comes in. So let me go ahead and run through this quickly, and we may have a little time for questions at the end. We have essentially this process that we want to accelerate for all of our development value streams, which is define what needs to be done based upon a request, explore it deeply, then build, lock in the design, test and fix up, and deliver. The key to improving our ability to go through this is actually through reducing the reaction time, expanding the exploration time, and then doing lock-in only at the last minute, so that fix up is minimal to zero. So the way we accelerate the cycle is that we can even get to the point where our reaction time to what's needed becomes negative, because we end up with an understanding already of what the problems are. We've been exploring them. We know what they're going to be. And in fact, we've already done some work on them because we're on cross-functional product teams, which are constantly doing that customer discovery and exploration. And because we're going to explore multiple open sets, we already know what's feasible or not. And our pre-opportunity team, which is on the product team, can be doing a lot of exploration. Then what we do is once we've gotten the go ahead on moving forward with a new feature, we can do a lot of exploration so that lock-in happens only at the last minute, and it allows for the best high quality solution possible. An example of this and where a lot of these ideas come from is from the process at Toyota, where under 2 years, they were able to deploy a new car model back in the 80s and 90s. That was during a time where General Motors took 8 years. The reason why was because of the fact that they used a platforming and tailoring approach to their project design. They also were constantly exploring early, and they used the set-based approach that we're going to get into here in just a minute. Essentially, vehicles refreshed every 4 years, but Toyota only assigned a leader to developing a new product 2 years ahead of release. They then knew how long it took in order to lock in on certain parts of the car's decisions as an architecture. There's 12 to 18 months for the style, 6 months out for a subsystem selection like the platform, 6 months out for supplier specs so that we could get back from them what we needed for production, and then only about 2 weeks for ramp up because they already had product lines that, based on integrated teams, right, concurrent engineering all the way through manufacturing, they had already set up manufacturing cells that were ready to ramp up production, and then they could replicate what was working in those early test cells. Now, let's say that you're in an area where you don't have a market cycle. You're like, market cycle? What are we talking about? We don't have a market cycle. We react based upon opportunities that come up, or maybe we're even in a contracting space. Well, the reality is that if you don't have a market cycle, that's no problem. You can take a look at the product life cycle where you are to go investigate and find the options of trying to either react to customers or proactively drive growth or market share. There is a wonderful understanding of the different types of innovation that comes from dealing with Darwin from Jeffrey Moore. And what he shows is that there's this huge market life cycle that includes kind of the new technology adoption life cycle that he's famous for. And there's a number of different innovation types, which are all about either new business models or disruption, developing new applications, driving up product features, creating a platform like For example, the iStore. And then once you've gone through these product innovations, you can do things that get you closer to the customer or things that improve your operational efficiency. And then you can also look to refresh your portfolio. And so all of these different types of innovation are available to you, but you can essentially group them into reactive development, where you're responding to a new opportunity, proactive, where you're growing the opportunities in the market because of the fact that you're driving up growth by pushing what's possible into the customer's minds, or you can keep and grow market share or sustain your price, as we talked about before with those value exchanges, by either getting closer to the customer. This is called customer intimacy, or becoming better at doing what you do, which is called operational excellence. And our goal then is that we want whatever we build to reduce defects. And when we're talking about defects in the form of a lack of usable knowledge, that included understanding what the customer wants and needs. Lots of places then to develop this learning. There's integration learning, innovation learning, and feasibility learning, all of which comes from teams working together at scale. And if you want proof that most of the work of what engineers do is learning, you can take a look at studies that were done, like the one that was done by Machi, Lanza, and Minelli, where they did a study about how much time developers spent in terms of actually coding versus other work. And what you can see here is that less than 10% of the time spent coding, 14% of their time is spent actually figuring out and organizing their work, and 70% is actually spent just learning with each other. So uh, this is just reinforcing that this is the work. The work is to learn. So the typical failure mode is that in conventional, we pick a concept before having fully explored it, just out of a little bit of brainstorming. Some solutions group then of highly paid experts decides what's going to be built. They decompose it to detailed functions for the lowest common denominator. And then the teams basically build, test, and integrate up. But the problem is that subsystems, are pushed beyond their abilities. We find out that most of them aren't really what the customer needs. And as we test, we end up looping back over and over again. And after you do that for developing and designing, you're going to do that again for manufacturing, and it leads to lots of delays. This is the reason why our probability of success in conventional development is really, really low. If you were just to have an 80% likelihood of going through stage gates where you're doing requirements and design and development and testing, and each one of them, you had an 80% chance of getting it right, your probability of successfully passing through all of those stages successfully is 25%. And even if you build in a lean agile way and you decouple all of these, you decouple the subsystems and you try to allow for everyone to work independently, you're still only getting to about 39% based upon reasonable estimates and giving each sub team 90% likelihood of getting it right. So both of these two approaches, lean agile or the approach of conventional, they both fail regularly because of the fact that they're just going with a single point solution. So you can't beat the odds related to this. Instead, you have to reduce the odds of failure by using sets. And sets are essentially our ability to, again, shift left and explore broadly, but shift right by attacking aggressively all of these potential options until the point of lock-in. And that's when, once we created usable knowledge in the form of trade-off curves and experiments, we can then converge on only the proven solutions. As a quick example, if you were building a bike and you had all these subsystems, right? Frames, gears, brakes, wheels, and then the integration, which is always a little bit riskier, you put that all together, probability of successfully building a bike that people like and work is only about 20%. But with just 4 concepts, okay, starting with just 4 concepts and integrating early and often, and we're not talking about a bunch, we're talking about like 2 to 4 concepts per subsystem, we can end up with a likelihood of success that's above 99%, simply because now you have options and you're exploring and learning early about what are the failure modes and the success modes. That's the key. And it doesn't take a lot to do it. When people see this, sometimes, especially engineers who have to do it, and they look at this and they go, wait, what? What are you talking about? I can't build 4 versions. I can barely get 1 out the door. It's like, that's not what we're talking about. What we're talking about is doing early prototypes. I'm gonna give you a quick case example, but, most of the concepts are actually gonna be tested early, and they're tested early when the cost of exploration is its lowest. If you test early when the cost of exploration is lowest, and therefore you explore broadly early on with those early prototypes like we just talked about, then you can over time converge down and you can level out your resource needs. In conventional, we do a little bit of exploration, and then we converge, and then all of the issues arise during testing, and we end up with just costs that go through the roof. So instead, let's test when cost of evaluation is early, and let's do it broadly, and we'll end up with much better, robust solutions. So the way that we do this is that uh, we're going to have teams that have what's called going through this double diamond approach, where the product managers are doing that very, very early work about understanding the problem, and they're bringing in the triad as needed. And then they're going through the empathy maps, the persona maps. They're starting on their journey maps. They're then defining the work, and then it's time to go through this set based delivery. So this is um, uh, the how to build it, and the how to build it needs to start with exploring and then converging. And this should all be done by the developers. Otherwise, you're creating lots of handoffs. Um, and as a reminder, that when you're going through this and you're doing story mapping, the goal is that you want to build to learn, not to earn upfront. The majority of the work, the majority of the work on an engineering full product team is building to learn. And so when you get together on your teams and you're looking to tackle a problem that has been identified as worth going after by the product manager and or the triad, you should then spend most of your time early on identifying the series of tasks that are being done, right? That's your users either operational value stream, or it's their day in the life. And then you should be ruthlessly looking at what are the actual things that need to be done at each one of the steps or tasks. And this is usually like 10 to 14 of those steps or tasks. And how can we group them and reduce them to the point where we can identify what would be an essential group that through doing either 1, 3, 4, 5, as you see here on the stories, or 1, 2, 4, 5, we're able to achieve an outcome, an outcome. So all of these stories work together on a story map to achieve an outcome that we can build, test, and learn. And then the learning is the goal because again, we're doing prototypes and we may build multiple prototypes. Um, and yes. And our goal is to therefore minimize the output, maximize the outcome. And at first, that is all about learning. So, as a quick case study in our last few minutes here, I'm going to go through how we did this at the National Archives when we were building what we call Google for the Government, or Electronic Records Administration 2.0. Essentially, National Archives gathers all of the records for all of the government, and it puts it into a discoverable place where it's used for everything from finding your old relatives to court cases and Supreme Court cases, to types of research that are done. And it's essentially an archive and Googleable record database, but it's enormous. We're talking petabytes of data. So hundreds of petabytes in the future. So we built a cloud native system and we decided to move forward with it, developing an MVP for how we would do the two key steps: processing records and making records discoverable. So making records that you can find, and making records and then finding those records. Um, and we did it on a very small team compared to the big conventional team that came before us that flamed out in about 8 years and spent over $100 million. So that was one of the worst projects of all time. And the government, this one, won an award. So the way we did it is we went through set-based concurrent engineering by exploring ruthlessly the different types of UI interfaces that would actually be useful for archivists, which I'm going to show you are not what you think. We also we did a lot of back-end testing. One team would take and explore options for a shared application database like Postgres. Another team would work together to conduct prototypes for the search engine and really tackle what was going to be a monumentous technical challenge of making searchable amounts of records that you can't store in house inside of servers. It's just that big. And it's literally petabytes of data take warehouses to store. And then when teams were doing that, as they explored and defined and came up with the solutions that were cutting edge, services not even released to the public, they could then share and that with other teams as essentially an API. And the teams could take it and then they could use it and they could also then dive into it and tweak it. So they just modified and inherited most of the work. Um, and so what we did was we essentially broke down all the systems into subsystems. We explored broadly, and then we were able to ensure success. And this is actually what Toyota does too, just as a mark of note. They usually, when they build cars, they do 10 to 20 exhaust types, 4 to 5 transmission types, 3 different air conditioners, and then they're constantly coming up with new engine platforms. But they do the same approach for physical systems as we do for digital ones. And so at first, all of the work that we're doing is what in Save4 and other frameworks we would call enabler work. We are exploring, we are learning, we are figuring out what will work. And then later we're building new features. So as an example, we actually had to solve 2 big problems. One problem was, how do you discover records effectively? And we had a couple of ideas. The team thought a basic search bar was going to be most liked because we all use Google. And our product owner thought that a complex search was going to be needed because he thought that that was the way in which archivists found things. They already knew what they were looking for. But when we developed prototypes, an engineer came in and they said, what about this tag search idea? It's a new approach, but it's working in some areas. So we said, yeah, let's try that too. Of course, the engineer was right. The engineer was right, and that's exactly what they picked, because it turns out that for an archivist, tag search allows them to rapidly explore in different branches where archives might be that they need to support a request. So then we looked at the browsing of these huge amounts of records coming back, and we thought, well, certainly, the tree view that you see if you open up your window is going to be required because we want to know the location. It's more detailed. That was the team bet. The product owner said, no, 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 we want file folder views. File folder views are the style that we want, and that's this one over here, because that's going to be what they're most used to using. They look at things in file folder views. But we decided, well, let's just throw in the icon view as well, because it's good to get feedback on all of it. And that, again, came from an engineer. Turns out that's the one that all the archivists wanted. They wanted the icon view. I mean, who uses the icon view, right? The answer is the person that uses the icon view is the person that looks at lots of different versions of a file. And then it turns out that the versions have different icons, and that's what they use in order to pick the right version. And how would we know that before we interacted with the customer? So this was another Spike story enabler we did early and we learned. So it was a fantastic way of learning. It had major impacts for those that don't know in terms of the back end and what we had to do. And that's the reason why we did it. So testing should be early and often. First, start with quick and dirty field tests, then look for failure modes and explore and figure out where are the edges of your solution. Tests should focus on finding failure locations, not testing specs. You have no specs yet. You're just trying to solve a problem and you're looking for where does our solution fail. And then with the right method and given the right complexity, you should pick what kind of prototype to develop. And remember that integration is your biggest risk because you're working on independent teams. So how often do you integrate? It depends. But it's almost always worth it to do partial integration. Sometimes and often you need to do full integration. And there are many different approaches to do that. Some of them include test doubles, integrating subsets, doing illustrative demonstrations, or proving that you can hit some non-functional requirements, or just less frequent integration, but then also making sure that you are able to work together later. So here's the end of this story, is that we had 2 teams. One of them did a lot of exploration early on and emphasized discovery and explored broadly with sets. The other one just jumped to a solution. And that team looked like they were getting ahead. and the other team looked like they were falling behind. Then in the next program increment release, the team that jumped to a solution started seeing a lot of issues and a lot of bugs. Next thing you knew, all of their work was bug fix. And meanwhile, the team that emphasized discovery actually smoothly delivered. And the the last part of the story not on the slide is this team then went to go refactor this team's work in the following increment. And so this is the reality is that if we want to be successful, we need to embrace this idea of using true agile at scale approaches, mostly discovery, and build to learn so that we are actually achieving the outcome. So um, we've solved the knowledge waste problem, and we've come up with how we can avoid being in endless meetings and dealing with issues where things don't resonate and always looping back. And the answer is simple, and it's very similar to how we shift left. This is how we shift right. First, use prototypes to explore early and often and make sure that we're integrating our ideas and testing. Second, dev teams do the exploration. Remember, all of our best ideas came from the engineers. And so that will be true. That's why you need whole teams to do solution exploration and convergence. And lastly, rigorously and frequently, you need to integrate and test your solutions. And that will make sure that you remove wishful thinking and you won't even have specs until it's time to lock in. And it's that delayed lock in, that expanded exploration, and the fact that you've already been exploring the problems. So you've even made the reaction time negative that allows you to outlearn the competition and win no matter what market or what industry you're working in. So I hope you've enjoyed this presentation. I know it went a little over. I'm going to also provide later an example of walking through the product kata, which comes straight out of the book, The Build Trap. I really appreciate everybody's time. I hope you had a wonderful experience here. We will be continuing with this series. We'll have one more that comes later in July, and I will be diving into how AI can make all of this even more fun, more rigorous. And you'll get the slides, you'll get the recordings. Saw a lot of requests for that, you betcha. So I'm going to stick around and answer another question or two. I just want you to know that there's a reckoning that's coming, but it's a good one. It's one that's going to tell us all that, you know, we need to get back to learning and stop with all this fake agile. And we need to start doing things with an understanding of the customer and the business and the technology. This is what it was meant to be. And hopefully we're helping bring it back to alignment of what it should have been the whole time. All right. I'm going to answer just a question or two that I see here. What do we mean by conventional development? The answer there is the development where we do linear stages of defining requirements and then specs and then building specs and then testing. So it's the traditional V model without fully cross-functional teams. The functions essentially hand off work to each other. Development process instead of a product. What we're talking about here applies to both products and services. Essentially, it's any kind of offering. Services need to be refined and made operational. Oftentimes they use solutions on the back end. I mean, nobody is able to do work without products at their fingertips. There's that piece, but there's also the continuous refinement of the service itself is something that actually is considered to be a blended value stream. And so this applies to that too. We need to experiment with new service offerings, new orders of operations, new approaches to solving our customers' problems, new ways of contracting, new ways of sharing risk. All those things apply to services. And so we should be able to do that, treating the service, they call it productizing the service, but even if it's a high-end premium service, you should be experimenting and learning too. How do you build, iterate on a product with low risk when you have access to data? When you don't have access to data. So if you're not allowed to have risk and you don't have access to data, the answer is going to be that you need to create prototypes that, well, frankly, you're going to throw them away, but you're going to use them for learning. And there's also other techniques you can use in the form of solution interviews, mock walkthroughs, things that you can then go develop the data, right? So we can either generate the data ourselves through creating these tests, or we can go explore the data that we already have. And if you can't explore data because you don't have access to it, you got to generate it. And I would say the first step is to get into a continuous discovery mode where you are discussing with your customers on a regular basis what their problems are, and then with your team, especially your core team, and figuring out what's the underlying issues. Because remember, we don't just take our customers' word for it, and they don't know what we can do and what the technology can do. So that's kind of the shorthand there. Um, Partnering. What do I think about patenting hardware products? I think it's a reasonable way to protect investments, and I think that there's a whole piece here about also how do you work with suppliers that we didn't get into. If you ever decide to come take our courses, you can, and we'll dive into that. But I mean, obviously, patent strategies are a little bit of a different thing here. But if you are delivering a great service and a great product, and you're learning quickly, you're going to outpacing the competition. They just can't catch up, right? I mean, we see the services out there that are beating the competition day in day out without any measurable patents. Things like Duolingo, when it comes to learning how to learning a new language. Nothing else is even close to it. They've completely changed the game with gamified approaches, and they continue to make it better. Their stock is soaring. Nvidia is also cutting edge. They use trade secrets, but they also use some patents, obviously. But IP protections are second to simply outlearning the competition and staying ahead. And is there a minimum scale to start applying to different approaches I shared? No, there is no minimum scale. The answer is that the approaches I just shared with you, they all work at every scale. The difference is that for this agile at scale approach, you have multiple teams working together that have much more integration risk. You have less integration risk at a smaller size. Instead, you have a lot more business model risk. You have a lot more risk of how do you break through into the market and get noticed. So your job is going to be to emphasize doing tests to make sure that you can actually get customers. It's not going to be as much about integration, but the all the approaches that I've talked about here still apply. I would just look to platform and abstract away as many technical risks as you can. Focus on the business model at a small scale. Okay, great. So with that, we covered all the questions. Hopefully you stuck around for them. If you ever thought about it, come join us at University of Maryland. We have lots of ways to learn. You can learn for free online. You can get degrees with us. We try to make it very accessible at all levels. So thanks so much, and I look forward to seeing you all in the next one.